Hello, everyone. Welcome to your Topic 1A ticket to retake your Topic 1A test. So I'm going to talk through these problems. You can watch all of this. You can fast forward to problems you have questions on. This is just a video to help you review in a way that helps you prepare for retaking that test. All right, so number one says create a subset of A. So that means what we create will come from this larger set A. But our subset B is going to include elements that are natural numbers and multiples of 3. So we have to review a little vocab here. Natural numbers are going to be your counting numbers that do not include 0 and no negatives. So for example, 1, 2, 3, 4, and so on. No decimals. This numbers you would count by starting with 1. So if we look, and then our multiples of 3, that's like 3 times 1, 3 times 2, 3 times 3. So if we look at our set A, first, what are our natural numbers? These negative numbers are not natural numbers, so we are not going to include those in our subset. We can see that 0 is part of our set, but natural numbers do not include a 0, so we do not want the 0. So far we're looking at a 3, 6, and 9 that are all natural numbers, so it meets that criteria. And then which of these are multiples of 3? Well, 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9, so those actually all are multiples of 3. So our subset B are the numbers 3, 6, and 9. All right, moving on to number 2, we're going to order the numbers from least to greatest. What we see are a variety of numbers. We've got fractions, we have square roots, decimals, all of the above. So the easiest approach on a problem like this is going to be if you convert all of these into decimals so that you can just compare decimal values. So 1/2 is a 0.5. It's a terminating decimal. -4, no change there. Square root of 7, when you type that into your calculator, you get a 2.645, maybe I'll say 646. And if we need more numbers, that is a rounded answer right there. So if we need to continue that, we will. All right, -5/4, so -5 divided by 4 is a -1.25. And then we have our 4.5, which is a decimal. All right, so our least to greatest, our smaller numbers will be the negatives, and negative numbers that are further away from 0 on a number line are the smallest numbers. So we have to decide between a -4 and a -1.25. -4 is going to be our smallest number. That is the furthest away from 0 on our negative side. So our smallest number is -4. After that would come this -1.25. So just be careful with those negatives. I am going to go ahead and just kind of keep track. Oops, I already made a mistake. So do you see how we typed in -5/4 to get -1.25? Our answer has to use the numbers from the problem, not the decimals we use to help us get to our answer. So I'm going to go ahead and erase that -1.25, and that is going to instead, we'll write it as a -5/4. All right, now I'm done with that. Let's see, now we've got positives. So we have a 0.5, a 2.46, and a 4.5. So this decimal 0.5 will be the next smallest. Then we'll go on to a 2.646 and then a 4.5. But again, we're going to write this as a 1/2. Then we've got our square root of 7, which is that 2.646, and ending with a 4.5. So those are our numbers from least to greatest. All right, identify each sum, product, or difference as rational or irrational. So what you want to look for on problems like this, rational numbers are ratios. And when you do your operations with rational numbers, you get back a rational number. So for example, here's 2/3, that's rational. We got a 2 over a 3 minus 4/5, 4 over 5. So when we have those ratios of integers, when we subtract those, we're going to get a rational answer back. So if you're working with all rational numbers, you can add, subtract, multiply, or divide, you'll still get rational numbers. All right, now I want to point out this one up here. This is a multiplication problem. So 12 over 37 is rational. Now this square root of 9 over 5. So the square root is a little bit suspect, but if we think about what is the square root of 9? The square root of 9 is actually a 3. So this fraction we could write as a 3 over a 5. So there's a rational number. So if we take a rational number times another rational number, then that product will also be rational. All right, so the first two that I kind of skipped over because I wanted to make sure we identified rational. This first one, we have a rational number, 2/3 plus, so square root of 7. If you were to type square root of 7 into your calculator, you would get a non-repeating, non-terminating decimal. So square root of 7 is irrational. That's going to make this whole fraction irrational. So if you have a rational plus in this irrational number, this one will result in an irrational number. All right, here we have a product, 1/2 rational times, there's that square root of 5. 5's not a perfect square like 9 was. Square root of 5 is, a 2-point, and then it's got this long string of decimals that has no reading pattern. It does not terminate. So square root of 5 is irrational. Divided by 5, this is an irrational number right here. When we multiply that by 1/2, that product will remain irrational. So on problems like these, kind of, look for, are you dealing only with rational numbers, a ratio, a fraction, then your result will be rational. But when these square roots pop up, you want to see if the square root itself is a perfect square, like square root of 9 was 3. So that was a 3 over 5, which made this a rational number, versus square root of 7. Type that into your calculator. I believe that's a 2-point something also with, just that string of decimals. All right, moving on to solving equations. We love to solve equations. So number 4, we're going to kind of follow a specific order when we solve. First, we look for distributing. This one is not distributing at all, so we'll just go ahead and carry the 1 down. But then we have this 3, which is negative because of the minus sign in front. We're going to distribute the negative 3. So negative 3 times a is a negative 3a. And then negative 3 times a positive 2. Negative 3 times 2 is negative 6. I'm going to carry down equals 7a. All right, before we even think about crossing our equal sign, we look for, do we have any like terms to combine? And right here we have a 1 minus a 6. I'm going to carry down the negative 3a, but then 1 minus 6 is negative 5 equals 7a. All right, the next thing we want to notice is that we do have a's, our variables, on both sides of our equation. So we're going to get the a's to the same side. We can do that with addition or subtraction. That negative 3a, we'll go ahead and add 3a to both sides. Negative 3a plus a is 0, so carry down our negative 5 equals 7a plus 3a is 10a. All right, go back to your variable. It's being multiplied by 10, so we're going to divide by 10. So our 10's reduced to 1, leaving us with a equals that negative 5 over 10, but that reduces to a negative 1/2. All right, number 5, let's take a look at another equation. Oh, there we go. So number 5, we're going to first do any distributing we can do. So I'm going to distribute this 9. 9 times x, those are both positive, so we have 9x. 9 times a negative 2 is a negative 18. Carry down the plus 8 equals, we have 6x will carry down. Now we have a positive 3 times a negative 2. It's a negative 6. Positive 3 times a positive x is a positive 3x. All right, so we are going to combine like terms before we think about crossing that equal sign. We have a 9x, but this minus 18 plus 8, those are like terms that we combine. So I'm going to carry down the 9x, but then negative 18 plus 8 is a negative 10. Over here, we can combine our x's. We have 6x plus 3x. That gives us 9x, and then minus 6. So one thing you might notice right now that we have all of our variables combined is we have a 9x on the left and a 9x on the right. So whatever 9x is, notice that those are the same. Is 9x minus 10 going to be equal to 9x minus 6? So right now I can tell you that no, those are not equal to each other, and they never will be. So we could write no solution. But I do want to follow through with this and kind of show you where this ends up if we don't recognize it at this point. So to get our x's to the same side, I'm going to subtract 9x from both sides. 9x minus 9x is 0. 9x minus 9x is also 0. Notice if this is 0, this is 0, we're going to carry down that negative 10 equals negative 6. There are no more x's in the equation. So if you have this term and you subtract the exact same thing, it equals 0. So there's nothing to write down. All we did was carry down the negative 6. Same thing over here. 9x minus 9x is not x. It is 0. That's why we crossed it off. All right, so when you no longer have variables to solve for, if you notice our equation does not have an x any longer, our final answer will be either no solution or infinitely many solutions, and it depends on if this is a true or false statement. Is negative 10 equal to negative 6? And that is not true, so that means that there is no solution to this equation. There's not a single value for x that we could plug in for our x's and get the left side to equal the right side. So this is just an equation that does not have a solution for x. All right, number 6. All right, so number 6, we're going to solve this equation. So this looks like an amazing equation. Look at all of those fractions. So one thing we're going to do is not turn these into decimals where we would have we'd have to round our decimals or represent a repeating decimal in an equation. We actually have to work with the fractions, or you could clear these fractions out. That's my method of working with equations with fractions. I think students would agree this looks kind of challenging, but once we get rid of our fractions, this equation feels much more doable for us. So this little fraction trick we can do, if you want to clear out your fractions, is we can take this entire equation and multiply by the denominator of your fraction. Well, in this example, we have 4 denominators. So what we need to find is a common denominator for all 4 of these fractions. The fastest way to find the common denominator is look for the largest denominator. In this case, it's a 12. And you want to see if the other denominators will fit into or multiply into that 12. So does 4 fit into a 12? Yes, it does, 3 times. Does 3 fit into a 12? It does, 4 times. And 4 fits into the 12, as we discussed there. So that means that 12 is the least common denominator for all of these fractions. So that will be the easiest number for us to use. So we're going to multiply every single term by a 12, whether there's a fraction or not. So what that's going to look like is we're going to do 12 times x. And some of this I just say out loud. 12 times x is 12x. Maybe I'll write it above just so you can see what I'm doing. Then we take that 12x and we divide it by 4. 12x divided by 4 is just a 3x. I'm going to carry down the plus. Now I'm going to do 12 times this x. Well, that's another 12x. That 12x divided by 3 is 4x. Carry down our equal sign. 12 times 9 is 108. And when we divide that by 4, we get 27. Plus 12 times 7 is 84. Divided by 12 is 7. And then this one had that x that's just going to carry down. Okay, well, this equation looks much easier to solve. So what we're going to do here is see if we would have any like terms on either side of your equation. On the left side, we have 3x plus 4x, which is 7x. On the right, we don't have any like terms, so we'll just bring down our 27 plus 7x. So again, we might notice we've got a 7x on the left and a 7x on the right. When those are the same, is a 7x plus 27 going to be equal to just a 7x? And I can tell you right now, it's not going to be equal, but why don't we follow through with our solving and just see how we get there algebraically. To get your x's to the same side, I'm going to subtract 7x from both sides. 7x minus 7x is 0. I'll carry down the 27 equals. Now on the left, 7x minus 7x is also 0, and there's nothing on the left to carry down. So I actually have to put a 0 right there. I have to put something on that side of our equal sign. All right, so does 0 equal 27? No, it does not. So this is a no solution example. We just had a no solution. Here's another no solution. I just want to make sure that we can see what an infinitely many solution might look like. So if I were to take, I'm just going to grab the equation from right here. Let's say we had a 7x, but also a plus 27 on the left. And on the right, we had that 27 plus 7x. Now, again, I'm making this up. This is not part of the problem, okay? This no solution right here, that's the answer to number 6, but this is just another example. I just want to make sure we're clear. Think of this as being a new problem. Okay, so is 7x plus 27 equal to a 7x plus 27? And I would say, yeah, I do think those are equal to each other. We can continue solving mathematically. We can subtract the 7x from both sides. 7x minus 7x is 0. We carry down the 27. 7x minus 7x is 0. We carry down the 27. And see how we have 27 equal to 27. Well, that is true. What that means is it does not matter what value we plug in for x. These will always equal 0. These will always equal 0. And we'll be left with that 27 equals 27 every single time. So the answer we would put for this equation would be infinitely many solutions. There's no possible way we could actually count up every single solution because every single number is a solution to this equation.